All right, let's talk about one of Python's secret weapons, something that's going to make your programs way smarter. We're diving into nested conditionals. This is all about teaching your code how to make decisions inside of other decisions. You've all seen this, right? You're playing a game, you open the settings menu. That's the first decision the game has to recognize. Then, inside that menu, you click the save button. That's a second decision. It's a decision within a decision, and by the end of this, you'll know exactly how to code it.
So how do we actually build logic like that? Well, the whole idea is that sometimes you only want to ask a second question if the answer to the first one was yes. It's about creating a clear path, making sure your program checks for things in the right order.
And the official name for this cool trick is a nested conditional. Honestly, the best way to picture it is like those Russian nesting dolls. You literally have to open the big outer doll before you can even get to the smaller one inside. Our code is going to work the exact same way.
Okay, let's start our investigation with the most basic version you'll see, a simple if statement tucked right inside another if. So check this out. Imagine a function that runs every time we click the mouse. The code first asks, hey, is the x-coordinate of this click greater than 200? If the answer is yes, and only if it's yes, it moves on to the next question, the one that's indented. It asks, okay, is the y-coordinate also greater than 200? So take a quick look at that logic. Where on the screen do you think a circle is actually going to show up? Remember, two things have to be true, one after the other. And there it is. The circles only appear in the bottom right corner. It makes total sense, right? The code first filters for any click on the right half of the canvas. Then, for just those clicks, it checks if they're also on the bottom half. Both tests have to pass. Simple enough, right? But this is where things get really interesting. Let's throw in a little plot twist. We're going to add an else statement and watch how it completely changes the game. So now we've added an else. It gives our code another option. But the most important detail here, the thing you have to see, is its indentation. See how it lines up perfectly with the inner if? That means it belongs to the y check. This one little detail changes everything. So here's the computer's new thought process. Step 1 is x greater than 200. If the answer is no, it just stops. Game over. But if it's yes, it dives into that inner block. Then it asks, okay, is y greater than 200? If yes, green circle. If no, well, that's when our new else kicks in and we get an orange circle instead. All right, new puzzle for you. With this else in the mix, where do you think the orange circles are going to show up? And, more importantly, is there any part of the screen where clicking still does absolutely nothing at all? And here's the answer. The entire left side of the canvas is blank. Green circles in the bottom right, and now orange ones in the top right. But if that very first if statement fails, if the click isn't on the right side, the program never even looks at the inner if or its else. That whole nested chunk of code just gets skipped. Now, get ready for this. This is the whole magic trick of Python. What if we took that else statement and just hit backspace once? Just unindent it by one level. That tiny little change completely rewires the program's brain. Now that else belongs to the outer if, the x check. This is everything in Python. With that one tiny change, what's your prediction? Where are those orange circles going to pop up now? And boom! Totally different result. Green is still in the bottom right, but now the entire left side is covered in orange. Why? Because the else is now saying, hey, if x is not greater than 200, draw an orange circle. The y-coordinate doesn't even get looked at for the orange ones anymore. This right here is why indentation is king in Python. Okay, to wrap this investigation up, let's look at one final piece of evidence. It shows that in coding, there's almost always more than one way to solve a problem. You can just flip the logic on its head. So in this version, we start by asking the opposite question. Is x less than or equal to 200? If it is, boom, orange circle. If not, well then our else block triggers. And inside that is where we finally nest our check for y to draw the green one. And what's wild is that this code gives you the exact same output as the last one we looked at. Orange on the left, green on the bottom right. It's the same destination, we just took a different road to get there. Understanding this kind of flexibility is a huge part of being a programmer. Okay, so this brings us to the big strategic question. We know how to do this stuff now, but when should you do it, and why? Because you might be sitting there thinking, hey, for that first example, couldn't I have just written if x greater than 200 and y greater than 200? And yeah, you're 100% right, you could have. So
Which way is better?
And here's the most important takeaway of the day. There is no single right answer. The best choice is whatever is clearest and easiest to read for you and for anybody else who looks at your code. Good programming isn't just about getting the right answer. It's about communicating your ideas clearly.
So we'll end on this thought. You now have this super powerful tool in your coding toolkit. You can check for a username and then check for a password. You can check if a player has a key and then check if they're standing in front of the right door. The possibilities are totally endless. So, what are you going to build first?